projectile motion, the definition of a projectile is an object that is thrown or fired into the air, subsequently moves under the influence of gravity alone. Okay, that's the definition of projectile. Other things that flies in the air like missiles, airplanes are not projectiles because they have motors on them that keep pushing them forwards. We shall ignore any effects of air resistance, so we will not be dealing with things like leaves, pieces of paper where air resistance has a large effect. Okay, so now we're going to look at a simple question. When you drop an object in the air, why does it fall to the ground? Okay, so Newton asked this question more than 200 years ago. Let's see how he analyzed the problem. So from a mathematical perspective, when the object is dropped from the air, the initial velocity of an object is 0. Okay, right, 0. If I started recording, I have. Okay, good. All right. So now we're going to continue. What's the next bit? Okay. All right. So when the object dropped from the air, the initial velocity is 0. When the object started moving towards the ground, the velocity has changed. Okay. Now, what does it change? It changed from 0. And when it changed from 0, and since the velocity has changed, the rate of change of velocity, which is called acceleration, rate of change of velocity, which is acceleration, is not 0. So therefore, oh, doesn't work. Okay, it's not 0. It's very slow. Okay. And then, let me read it, it's not 0. So this is called the acceleration due to gravity. And record, okay, actually I should make it a bit smaller. Okay, good. All right, so, is it recording now? It is. Okay, good. Okay, it's not 0. So this is called the acceleration due to gravity. Due to gravity. So there's a special name for the acceleration. So when an object falls from the air, it's due to the acceleration due to gravity. Okay? And the symbol for acceleration due to gravity is g. Okay? And the value of the acceleration due to gravity is 9.8, approximately 9.8. Even that's approximate. Meters per second square. And sometimes this value, because it's so close to 10, to make the calculation a bit easier to do, we round it to 10 meters per second square. Okay? So what that means is that the speed will increase by 10 meters per second every second. That's what the acceleration equal to 10 means, that every second you speed increase by 10 meters per second. So roughly speaking, if you drop an object from a cliff, after the first second, the speed is 10 meters per second. But if you wait for another second, it gets faster, become 20 meters per second. And after 3 seconds, becomes 30. So that's why people, if you fall from a cliff, it's very dangerous because it gets faster and faster, and you will get severely injured. Okay. All right, so this value of g is constant near the surface of the Earth. And when you throw things in the air, the only acceleration of the object is the acceleration due to gravity, as in the vertically downward direction. Okay, so we're going to do a question on that. So we're going to model when you throw a stone from a top of a building. How far has it traveled? How fast is it going after 5 seconds? So we can answer all of these using mathematical analysis. Okay, so we're going to start with, so we're going to draw a simple building. So there's a building, so you're going to drop it towards the ground. So we're going to start off with, let's make this as the origin, okay? The top of the building as the origin. And the stone was dropped from the air. So we're going to start with, this is y, okay? Y double dot. So the only acceleration is acceleration due to gravity. We're going to make the upward direction positive, downward direction negative. So in this case, the only acceleration experienced by the object is the acceleration due to gravity, which is 9.8, and it's going downward direction, therefore the acceleration is negative. So we'll start off with y double dot is negative 9.8, and we're going to find y dot by integrating in respect to t. And that will give you negative 9.8 t plus c. Remember, always add a c after you integrate. And to find out the c, we note that when t equal to 0, it's on the top of the building, which we're going to make it equal to 0 to make the calculation easier. So when t is 0, y dot is 0, therefore c equals to 0. And you update your formula. So the formula for the velocity is negative 9.8 t. I will draw a box around it because it will be useful later on. So the hard part is to work out the equation. Once you work out the equation, the question will be easy to do. Once you do that, let's find y. And to do that, we integrate that again, which is negative 9.8 t squared on 2 plus c again. And when t is actually y dot 0. Y is 0. So y dot 0 because the stone was dropped from the air. And when it's dropped from the air, it means that there's no initial velocity. It's y dot 0. Okay, and then we're going to find out the equation for y. Y will be, so we'll substitute 0 in there. That will be 0 equal to 0 plus c, so therefore c is 0. So therefore, y equals to negative 4.9 because I divide 9.8 by 2. That's the equation for displacement. So you get 3 equations. One for acceleration, one for velocity, one for displacement. And we're going to use the formula for velocity and displacement to answer the question, how far has it traveled and how fast is it going after 5 seconds? Because they're all in terms of the time. So if I know the time, I can work out the speed and the distance traveled. Okay, so let's work them out. So what we do is when t equal to 5, let's work out the displacement. The displacement will be negative 4.9 times 5 squared. And if you use your calculator, you will get 25 times 9.8, 4.5. 4.9. Yeah, it will be negative. Is that right? No, I put too many. Yes. Okay, so negative 122.5. That will be, that the negative means you're going below 0, so the distance traveled, you would have traveled 122.5 meters. Let's work out y dot. Y dot will be negative 9.8 times 5, so your speed after 5 seconds will be about 50 meters per second. So if you go 9.8 times 5, that will be 49. So it will be negative 49 meters per second. So what you could say is, the stone traveled a distance of 122.5 meters with speed 49 meters per second, which is pretty fast. Which is almost the speed of when you drive a car in a suburban area at 50 meters. Actually, no, that's 50 kilometers per hour, so it's different. Okay, got mixed up. Okay, but we don't know. All right. All right, let's move on. So, as you can see, using the 3 equations of motion, acceleration, velocity, and displacement, we can work out both the speed and the distance traveled. Okay, so that's a simple problem. We're now going to look at more complicated problem in 2 dimensions. So this is 1 dimension, it's just traveling vertically downwards. So now we're going to look at what happened when we have to throw something in the air at an angle. Okay, so we're going to go to the next page. All right. So again, you don't really need to know much physics for this topic, but if you know some, it doesn't really help you a lot. So do not feel bad if you haven't done physics. Okay, and if you've done physics, you have to learn everything from scratch because it's a bit different. Okay, all right. Actually, there's no video. get rid of that. You watch some later on. Okay, so actually, I don't want to cross it off. So we need to know that there's two components of velocity that are independent. So in the final section, we're going to consider a case of motion in 2 dimensions, the motion of a projectile, like a thrown ball or a shell fired from a gun. So everyone can see a projectile moves on a parabolic path. Our task is to set up the equations that describe this motion. So we're going to look at this diagram here. So we'll throw something in the air. It moves on a parabola. And this angle alpha is called the angle of projection. So write down this is angle of projection. Okay, good. So when you throw something in the air at a velocity v, there's 2 components of velocity. There's the vertical component, and there's the horizontal component. And these 2 components are independent. Okay, they're independent of each other. So we can analyze them separately. So x dot and y dot. So what we do is we're going to look at some simple examples. So find the horizontal and vertical components of velocity moving with speed of 12 meters per second and angle inclination 60 degrees. Okay, let's draw the diagram. So you throw something in the air at 12 meters per second, and you're going to find out what the horizontal speed is, what the vertical speed is. Okay, and to answer this question, you just have to use trigonometry because this is 60 degrees. So you can work out the opposite and the adjacent side of the right angle triangle. So the best way to do this, so what you could do is just go like x dot over 12 equal to cos 60, right? And then x dot equal to 12 cos 60, and you know cos 60 is half, so it's 60 meters per second. Like that. And to go work out y dot, it will be the same thing. You can just write it down straight away. Just write y dot as equal to 12 sine 60. So you can write that straight away. So remember, the vertical component is the sine. The horizontal component is the cos. And sine 60 is root 3 on 2, which is 6 root 3. Let's calculate what that speed is. The speed will be 6 root 3, which is equal to 10.4. Now, why do I want to work out in decimal? So you can compare with the actual velocity. Notice both the horizontal component and the vertical component of the speed are both smaller than the actual speed. So while it's thrown at 12 meters per second, it's only moving forward at 6 meters per second, which is half of the speed that it was thrown. And it is rising at 10.4 meters per second. Okay, so we need to know the difference between the components of velocity and the actual speed of the ball. Okay, all right, let's move on to the next question. What if the angle negative means that it was thrown downwards? So it was thrown like this, below the horizontal, at 60 degrees. So that means y dot will be downward, x dot will still be forward. So it's still moving forward, but then it's going downward. Okay, so let's answer them. So like before, you don't have to do a lot of working, just write x dot equal y dot equal, right? X dot equals to, it's still at 12 meters per second, so write 12 cos negative 60. And the other one, 12 sine negative 60. Just go like this. Okay, so what would that be? If you do on a calculator, cos negative 60 is still positive, so you still get 6 meters per second. Whereas sine negative 60 will be negative 6 root 3 meters per second. As expected. So y dot is going down, x dot is still going forward. Yep. Okay. So we've done these 2 examples. There's one more we have to do. Now, what if they don't give you an angle? They give you tan alpha is 33/4. So you have to do it slightly differently. So what you do is this. So you go like that. So you go angle alpha, like that. Okay, so in that case, we don't have the angle. So what you do is this. So you got 3, that's 4. And using Pythagoras, you will have 5 there. Okay. Now, remember, the actual ball was actually thrown at 12 meters per second. So the 2 triangles are similar, right? So to work out x dot, you go x dot equal to 12 cos alpha, and cos alpha can be found from 12 times cos alpha is adjacent over hypotenuse, so 4 over 5, right? And then if you times 12 by 4 over 5, that will be 8 times 12, which is 96, so 9.6 meters per second. And on the other hand, to work out y dot, you have to go y dot equals to 12 sine alpha, which is equal to 12 times 3 over 5, which is equal to 6 times 12, which is 72, so 7.2 meters per second. Okay, so note that what you do when they give you tan alpha is 3 over 4, you do not need to find the angle alpha because you will not be exact. Okay, so we've got all three different examples. Now we have to do the reverse. What happens if we give you the components and work out the speed and the angle? So let's do that. So we draw the diagram. X dot is 4 and y dot is 3, right? And then that means the actual speed is going that way. So you have to find two things, the angle and the speed, right? Now to work out speed, you just have to use Pythagoras. So v squared equal to 4 squared plus 3 squared. So the actual speed is 5 meters per second. And the angle can be found by using tan. So right, tan theta is y dot over x dot, 3 over 4, and you just go shift tan to get the answer. Okay, let's work out. So you can use your calculator. Make sure you put in degree mode. So it's in degrees, so it's easier to read. Tan inverse of 3 divided by 4. 36, so about 37 degrees. Okay, like that. I'll try the next one. Have a try. Draw the triangle and you can work out all the details. Right, let's continue. So the next one you go now, x dot is 5 means going forward, and y dot is negative, so it's going downward. Okay, so therefore to work out the speed, you go like this. So you go v equals to square root of 5 squared plus 12, 2 squared. If you do that, it will be 25 plus 4 will be 29. That's the speed. And then the angle you can find by doing shift tan. Now you can put the negative or positive, doesn't matter. You just go 2 over 5, or you can put a negative, but you get the same angle. So that you just get a negative angle if you put a negative. So if I put 2 shift tan 2 over 5, but if you put a negative, it just give you a negative angle. Okay, the negative angle means that it's below the horizontal, so you get 21.8 degrees negative degrees. Okay, all right, good. So it's all done, so we're going to move on after this. All right, take a second to finish off. All right, so we'll go to the next page. So the next page just summarizes all the things we just discussed, and then we're going to do some simple problem. Okay. Okay, so main thing is that y dot x dot are independent. We'll analyze them separately. Okay. All right, let's go to the next page. So every projectile motion is started with this equation. Every. So you always start with this. No matter what, the acceleration in the horizontal direction is always 0, and the acceleration in the vertical direction is always equal to negative g. Okay, that's the two things. That is always the same. And to find the horizontal and vertical components of velocity in terms of speed, we use these two equations as we've seen earlier, right? So x dot is the horizontal component, y dot is the vertical component. And to work out the speed, we use Pythagoras. And to work out the angle, we use tan. Okay, so it's all done here. So let's highlight this. Let's rub this off. So let's highlight this box. Let's do a highlight here. And then highlight the two equations, highlight these two, highlight the speed. All right, done. Okay. All right. Once you do that, now we're going to look at example 4. A ball is thrown with initial velocity of 40 meters per second, angle of projection 30 degrees from the ground. Find the sixth equation of motion using g equal to 10. Okay, so this is what you do first. You might like to draw yourself a picture. So it's thrown in the air at 30 degrees. So of course not to scale, 30 degrees. So we want to work out the three equations of motion, six equations. So the first thing you need to do is look at what the displacement, the position, and the speed at the beginning. When t is 0, what's x and y? Well, it's both 0 because we assume that it's thrown from the ground. So start from 0, okay? And then we have to work out the initial value of x dot and y dot. And to ask this question, put 30 in this triangle. And then you got the x dot here and the y dot. And the speed is 40. And using the formula we got before, you just have to write down x dot is 40. Let's write it here. X dot equal to 40 cos 30. Using the exact value will be cos 30 is root 3 over 2, so you get 20 root 3. And same for y dot equals to 40 sine 30, which is half. So I want to put this here, 20 root 3, because you have to refer to them later on to find c. All right, so hopefully you all got that. Take a second to write it down. And then we're going to get the sixth equation of motion. Sixth equation of motion. Why there's six equations? Because there are acceleration, velocity, and displacement. And you have to do it in both the horizontal direction and the vertical direction. Okay, let's start now. Now, let's recap. Remember, every time you start with these two. Always start with these two. So let's start with x double dot. X double dot equal to 0. That's your first step. X double dot equal to 0, and then we're going to integrate x double dot. And when you integrate 0 is 0, but you have to add a c. Does that make sense? You integrate 0 is 0, but you get an extra c. Now, how do I find c? You look at when t equal to 0, that's where you look at the top. T 0, what's x dot? 20 root 3. X dot equal to 20 root 3. Right? And then what do? We have to find c. So write 20 root 3. And when you substitute t equal to 0, it's still equal to c. We found what c is. X dot equals to 20 root 3. Okay, so we're going to draw a box around it. We're going to use it later on. We don't really need acceleration, just the velocity. That will be more important. Okay, all right. Let's move on to do the next bit. Let's find x. How do we find x? We integrate again. So write 20 root 3 t plus c. And like before, we look at the stuff above. When t is 0, x is 0. So write t is 0, x is 0. And you get 0 equal to 0 plus c, so therefore c is 0. Now update your formula, therefore x equal to 20 root 3 t. Box. Okay, so you are only mainly going to use velocity and displacement. You will not be expected to use the acceleration because it doesn't really tell you much, just 0, constant, right? You're mainly going to answer the question about velocity and displacement. That's why I emphasize on this. There's 3 equations here. And then we're going to start with y double dot. So that's the horizontal component. Now we're going to look at the vertical component. Y double dot is always negative g. In that case, g is 10. So you write negative 10. Okay? And do the same thing again. Integrate to find y dot, integrate to find y, using this initial condition that I've shown in the table. So let's do y dot. So y dot equals to negative 10t plus c again. And you're going to find c when t is 0, y dot equal 20. So write 20. Right? And then you update your formula, 20 equal to negative 10 times 0 plus c, so therefore c equals to 20. Update your formula, and y dot is negative 10t plus 20. Draw a box around it. Okay, actually I should make the screen a bit bigger. Alright, continuing on, we're going to find y, so we'll do y equals to negative 5t squared plus 20t plus c. And like before, we use the initial condition when t is 0, y is 0. So when t is 0, y is 0. So write 0 equal to 0 plus c, therefore c is 0. So you update your formula, y equal to negative 5t squared plus 20t, and then you draw a box around it. So there's your 6 equation of motion. The 2 acceleration, 2 velocity, and 2 displacement. All right, once you get the equation, we're going to answer questions about the projectile motion, which you will be on next page. Or the next page, all the formulas are already written down, so that will help you. Okay, all right. Hopefully all finished. All done? Okay, we're going to answer a question about this, so we're going to go to the next page. So what you need to do is to substitute the time into all 3 equations, work out the displacement, this velocity, and then we're going to calculate the speed at each point. Let's start to do that. So let's substitute t equal to 0 into this equation. That gives you the initial position as expected, 0, 0. Then substitute t equal to 1, you'll get 15, isn't it? And then 20 root 3. And then after 2 seconds, it will be 40 minus 20, so 20, right? And now leave the calculation to you. Substitute 3 equal to t equal to 3, you should get 15 again, and you should get 0 again. Okay, so you can work this out by substituting these numbers into this y equation. On the other hand, you will see the x equation, you just keep increasing by the same number. So the next one will be 40 root 3, 60 root 3, and 80 root 3. We can actually plot this information on the graph below. Let's do that. So basically, every second is moving horizontally at 20 root 3 meters per second. So the next one will be 40 root 3. The next one is 60 root 3, followed by 80 root 3. Remember, that's like the x-axis. This is the y-axis. Okay, 2-dimensional motion. And the height at 20 root 3, the height is 15, right? Increase to 20, 15, and then 0. So it goes to 15 after the first second. And then after that goes to 20. And then goes back to 15, goes back to 0. Okay, so it takes 4 seconds to go back to the ground. All right, good. So now we can see that this equation helps us to work out the position at each of these points, at each of these times. So this is when t equal to 0. This is like t equal to 1. This is t equal to 2, t equal to 3. And after 4 seconds, you reach the ground. Okay, so the 4 seconds, the time when we reach the ground is called the time of flight. How long it takes to fly. Okay, time of flight. So 4 seconds. So the time of flight equal to 4 seconds. All right, so we see that. Now, if you remember, this is a parabola, so it really relates to the topic of parametric equations. So you can think of t as like the parameter. Okay, you can think of t as the parameter. And it has this physical interpretation of being the time, the third variable. Okay, of course, in the parametric equations, t can be negative, but in this part, we have to put into context, t is time, t time can only be positive. Okay. All right, so we found this thing. Let's move on to do more things. Let's look at the velocity. Let's substitute these numbers. So let's substitute t equal to 1, t equal to 2, etc. So when t is 0, y dot is 20. And when t equal to 1, y dot is 10. Remember, acceleration is negative 10, means you're losing 10 meters per second every second. So every second lose 10 meters, right? So 20, 10, next one will be 0, next one will be negative 10, negative 20, right? Because acceleration due to gravity is 10, negative 10 means that every second you lose 10 meters per second from your y dot. Now on the other hand, x dot is constant, so every second the speed is the same. No change, because x double dot is 0. No acceleration. So no rate of change for velocity. All right, so we've got both of these. So now we can work out the actual speed of the particle. V equal to x dot squared plus y dot squared. Let's work them out. Okay. So let's use Pythagoras to work them out. So using your calculator. So you go 20 square plus 20 root 3 square. And what do you get? You get 40, right? 40 meters per second as expected. And then after 1 second, it gets slower, isn't it? So the vertical component gets smaller, becomes 10. Oh, I connected. Must be. On now. Charge. Okay, good. All right, let's continue. Okay, all right. So what's the next one? Next one will be a decimal. So you get 10 equal, and then just square root the answer. You get 36. 36. And then next one you will do, what if you go, that becomes 0. That becomes 0. For the next one, 0 squared plus this square, you get this and then square root, which is 34.6. So the speed gets smaller as it fly, and then after that, it starts to increase again. So if you go to the next one, you go back to negative 10 square, and when you square it, become positive. And then you just square root answer. Okay, so we get 36, and then 40. Okay, that's the actual speed of the projectile. And then we can work out the angle for each by doing tan inverse of y dot over x dot. So you go, the first one, you go tan inverse, make sure you put it in degree mode, 20 over 20 root 3, you get this, 30 degrees. The next one, it becomes 10. You get 16 degrees. And the next one is 0 degrees. And you get negative 16 degrees, negative 30. We're going to display all this information on the diagram. So basically, it starts off with 30 degrees at 40 meters per second. The next after that becomes 36 meters per second. 36 meters per second at an angle of 16 degrees. And then after that becomes 34.6 meters per second. And then after that, the angle becomes negative because it's going downward. 16 at 36 meters per second. And then last one will be 30 degree again. Okay, at 40 meters per second. So the starting speed and the final speed are the same, right? So it's by symmetry. And then we'll have to explain a few words. So the impact angle is the angle when you hit the ground. That's 30 degrees. That's called the impact angle. And the impact speed is when the speed when you hit the ground, 40 meters per second. Okay? And we'll note that you reach the maximum height when y dot is 0, when it stops rising. Okay, that's how we find the maximum height, when y dot is 0. What else are there? And then you reach the ground when y is 0. So note the difference. When you reach the ground is when y is 0. You reach maximum height when y dot is 0. I think that's all we have to do. Okay, good. So hopefully you can see the picture. So the y dot x dot gives you the speed and angle, and then to the x and y give you the coordinates of each point. Okay. All right. Okay. What else? Okay. All right. Good. All right. Think about it, and then we'll do some other questions. Right, we'll do 2 more pages, then we're done. 2 more page. 2 more page. Okay, all right, 2 more page. Okay, let's move on. Okay, all right, let's move on. Okay, hopefully all finish. All finish. Good. Move on to next bit. Okay, a body is projected horizontally from the top of a cliff 20 meters per second, 20 meters above the water at a velocity of 30 meters per second. Find that. So there's a cliff, and then you got like this, it goes like that, right? So let's write down, so we're going to make this one y, this is x. Okay? So at the beginning, we're going to make the bottom of the cliff the origin. So when t is 0, x is 0, but y is 20, right? Starts off 20 meters. And then we have to work out both the x dot and y dot. In this case, the angle is 0 degrees, right? And if you work out, x dot will be 20 cos 0. Now, cos 0 is just 1, right? So you get 20. Whereas y dot will be 20 sine 0, which is 0. So it's projected horizontally, means that the y dot is 0. X dot is 20. Okay? Meters per second, meters per second, meters, meters. Okay, after you do that, we're going to work out the equation of motion. So, like before, we're going to do x dot and y dot. Okay, so we'll start with x double dot equals to 0. X dot equal to c. And then we know that when t is 0, c equal to, so when t is 0, x dot equal to 20. Therefore, you get x dot equal to 20. Okay, I skip some steps. You have to write c equal to 20. And then after you got x dot, you find x by integrating again 20t plus c. When t is 0, x is 0, therefore c is 0. So you get x equal to 20t. Okay, so we get these equations. This one, and this one. Okay, these are the first 3 equations, and then you do the same thing to find y dot. Okay, if I have a try find y dot, I'll rub this off so we have enough space. Okay, so we're going to do y dot. Now y double dot, we're going to use g is g equal to 10 to make it easier. So okay, so let's do that. So y double dot equal to negative 10. Y dot equals to negative 10 t plus c. Okay. Now how do we find c when t is 0? Y dot equals to 0. Okay. So you update your formula. Y dot equal to 0. 0 plus c. So c equals to 0. So you get y dot equal to negative 10t. Okay, then after that, do y equal to negative 5t squared plus c. And when t is 0, y equal to 20 this time. Oh, that's a 30. Sorry. I made a mistake. That should be 30. That should be 30. All right. 30 here, 30 here. Right. 30 meters per second, so that will be 30. 30, 30 T. 30, 30 T. Okay, all right, good. So now we update your formula. So therefore 20 equal to 0 plus C, therefore C equal to 20. So now we work out what Y is. So Y equal to negative 5T squared plus 20. All right, draw a box around them because you will use them later on. Y dot, and that. But you only have to use 4 equations. Okay? All right. So use this equation and then we're going to answer the next question. When you're ready. Right, give it a couple more seconds. Okay, good. We'll go back to this. Okay, all right. Okay, hopefully you're finished. Let's continue. All right. Okay, let's answer the question. How long does it take to reach the water? Okay, to reach the water, what's the value of Y? Y will be 0. When you reach the water, Y is 0. Okay? So now you get the equation. So Y equals to negative 5T squared plus 20. Make that equal to 0. Let's see how long it takes to drop on the water. So that means negative 5T squared equal to negative 20. T squared equal to 4. We take this positive square root because time is positive. So it takes 2 seconds to reach the ground or reach the water. 2 seconds. Okay, good. The horizontal distance traveled. So how much distance did it travel? So we have to substitute when t equal to what's x? X equal to 30t. Substitute back in. X equal to 60. 30 times 2, which is 60 meters. Okay, like that. So it's pretty straightforward. All right, so on the diagram, you can indicate that it has traveled 60 meters. Okay, not to scale. And it reached the ground after 2 seconds. Okay, good. All right, done. Let me ask you a question where you have to think. If you've done physics, that may help you, but think about the mathematics involved. We just done the question. Now, remember, it was thrown forward at a speed of 30 meters per second, right? This is 30 meters per second. But what if I increase the speed to 50 meters per second? Find the time taken to reach the water. Actually, would it take longer to reach the water? Would it take 2 seconds, or more than 2 seconds, or less than 2 seconds? What do you think? And explain why you choose the answer. So instead of 30 meters per second, 50 meters per second. Does it take longer than 2 seconds, or shorter than 2 seconds? Why? It's independent, yes. It would be the same. So let's show you a video why it's going to be the same. Actually, before we do that, let's do it again. Now, if you start with the equation, y double dot equal to 0, isn't it? Right? And when t is 0, y dot is 0. So therefore, the equation for y dot is exactly the same, which is negative 10t, and the equation for y is still the same, which is equal to negative 5t squared plus 20, right? Whereas the x, the only difference is that the x dot will be different. The x dot will be 50t instead of 50t. So therefore, the time it takes to reach the water will be the same because the y dot is still, the equation for y is identical. So it still take 2 seconds to reach water, okay? And why is it the same? Because the vertical and horizontal component are independent. So by making by using a different x dot, it doesn't affect your time it takes to drop to the ground because they're independent of each other. Now that's the mathematical analysis, and you can also see it physically on a video which I'm about to show you. So you can see that, let's make it a bit bigger. So he's going to drop 2 balls. One ball is going to go down, one ball is going to push forward at the same time. So, but it's going to be in slow motion. Now watch carefully. So he's going to take the ball and make it louder. Yeah, see? So they drop on the same time. Okay, let's go back again. So one ball has been thrown forward, one ball has thrown down, right? So they are dropping at the same time, right? They drop at the same time, and so they will reach the ground at the same time. Now, the reason why this is true because the equation for the vertical component is the same because they're independent of each other. So see, the equation for x is changed, but y is the same. So therefore, it still takes 2 seconds to reach the water. Okay, does that make sense? Yep. All right. So they're independent. So we got one more question to do, and then we're done. Okay, example 6. All right, so we're not going to keep deriving the 6th equation every time because it's boring and it won't take you that long. So let's try the next question. Okay, the next question, the equations are given to you, and they're going to find out how high the ball rises. So to answer this question, remember to put y dot is 0. Okay, y dot is 0. And then the next bit you're going to do is to work out, so you have to find out what y dot is. So y dot is when you have to differentiate negative 10t plus 20, differentiate that, put that equal to 0. So 10t equal to 20, t equal to 2. So it takes 2 seconds to reach the top. After you find out how high it rises, oh no, that's the 2 seconds. You have to find how high it rises. So you have to write down the equation for y. Okay, and then you substitute t equal to 2. So you get negative 5 times 2 squared plus 20 times 2 plus 25. And then use your calculator. Negative 5 times 4 plus 20 times 2 plus 25 equals to 45. So you reach 45 meters above the ground. Okay. And what is the speed then? How far is it horizontally from the stand? Let's work out x. So x equal to 20 root 3. So after 2 seconds will be 40 meters root 3 meters from the stand. And then we're going to find the speed. To work out the speed, you find out x dot. X dot will be equal to 20 root 3. Y dot will be equal to negative 10t plus 20. Substitute t equal to 2, which is 0. Okay, so to work out the speed, you go x dot square plus y dot square. And then if you work it out, now because y dot is 0, 0 will be 0 square plus 20 root 3 square. It will just be same as the horizontal component. Okay. All right, so we answer all these questions. Maybe we'll draw a diagram to label what it looks like. So we're going to draw a simple diagram. So basically, from a stand, that's 20 meters above water. So This is y, this is x, and then it was projected at an angle of 30 degrees from the horizontal at 40 meters per second. And then it's going to go like this. And then after 2 seconds, it is 45 meters above the ground, horizontally 40√3 meters from the stand. Okay, and the actual speed is like this, right? That's the actual speed at 20√3 meters per second. That's what it looks like. And then after this, find the flight time, range, and the impact speed and angle. Okay, so to find the flight time, that's when you make y equal to 0. And you find the time, substitute t back into find x, and then find the impact speed and angle. Okay, so v and theta. Okay, have a try, and then we'll derive the Cartesian equation. Oh, spend the whole lesson. Okay, all right. Next lesson I think will be a bit faster. Let me see. So it's 2 pages. We'll do 5 pages next lesson, or maybe more. And then we'll do HSC questions, which also take a while. So we'll spend 3 lessons on this. Yeah, I think revision. Okay, let's move on. Okay, let's do flight time. So to do the flight time, all you do put y is 0. So you get -5t squared plus 20t plus 25 equal to 0. Divide everything by -5. Divide by -5. So you're going to end up getting t squared minus 4t minus 5 is 0. T minus 5, t plus 1. But t can only be positive. So it reached the ground after 5 seconds. And then find the horizontal range. So x equal to 20√3t. Replace the t by 5. So that tells you how far you travel after 5 seconds, which is 100√3 meters. And the impact speed and angle. So the impact speed is when you go find v. So do x dot, which is still 20√3. Y dot equals to -10t plus 20. Substitute 5 in. You get -30. So the impact speed, which is v, you go 20√3 square plus 30 square. And then use your calculator. So you do this, 20√3 plus, we'll have to put bracket square plus 30 square equal, and then square root 2100. Oops. 2100, which is equal to the impact speed will be 45.8. So 45.8 meters per second. Okay. And the angle can be found by using tan. So write tan theta. Maybe just take the positive y dot over x dot. And the y dot is 30 over x dot. X dot is 20√3. And then you just shift tan on it. So shift tan 30 divided by bracket 20√3. 40.8, 40.9, so about 41 degrees. Okay, so basically on your diagram, the angle it makes with the ground, so the angle, the actual speed will be 45.8 meters per second with the angle of 41 degrees. So that's the impact angle. And then it has traveled a total distance of 100√3 meters. Okay, and it reached at that point after 5 seconds. Alright, done. And then we're going to do the final thing, which is the Cartesian equation. Okay, let's do that. Cartesian. Okay, So Cartesian, so how do we find Cartesian? So just like parametric equations, so we've got two equations, x equal to 20 root 3t, and then y equal to negative 5t squared. So what you need to do is to eliminate time. Eliminate time. Eliminate time. So how do we eliminate time? Make t the subject, x over 20 root 3, substitute that into the equation, and then you just use algebra. Like that. And then we're going to do calculations. So 20 that get cancelled. So you end up getting, that's 400 times 3, 1,200. Right? 400 times 3. Yeah. And then you're going to divide by 5. So you get 240. So it'll be negative x squared 240 plus x over root 3, which is 25. So that's called the Cartesian equation. Okay, Cartesian equation. And as you can see, it's a concave down parabola. Okay, so the trajectory, the path of the projectile is a parabola. Okay, so this equation is the equation of this curve. Okay, all right. All right, good. So now you should be able to do the exercise from the textbook. So we're going to, so you do exercise 3G. Okay, exercise 3G. So let me pause the video.